everyone. Today again I'm here to discuss with you the frictional clutch. And as you know, I am Dr. Irshad Ahmed Khan, Associate Professor in Department of Mechanical Engineering, Sagar Institute of Research and Technology, Bhopal. And this is one of the very important element of machine, especially in the automobile, the clutch, or we can say the frictional clutch. So frictional clutch, we know that this is used to engage and disengage the driven and driving shaft at our wheel. So when we are using the transmission system, so while shifting the gear, and we have to be disengage the driven and driving shaft. So this is very important element of machines or in automobile. So let's discuss the single disc or plate clutch, or this diagram you can see. This is a single plate clutch. A single plate clutch is used in the big vehicle, and start from the car. Where in the car you can see this kind of clutch place has been used. But other hand, in the two-wheelers, we are using the multi-plate clutch. So due to the engine of the two-wheeler is compact in nature, so to make more compact, we are using the multi-plate clutch. And when the vehicle is size big like car and above truck, so we are using single plate. Single plate clutch gives the more positive drive or more power transmission. So let's discuss the single plate clutch. So you can see here, this is a typical example of that. Here in this direction, from my right side, the one W load is applied here. So this frictional surface, this frictional surface are come in contact, so the clutch start walking. So let's discuss some elements or some parameters which is used here. So let's discuss T is the torque transmitted by the clutch. P the intensity of axial pressure which is acting on the contact surface, and they are also held together. R1 and R2 is the radius, external radius is R1 and internal radius is R2 of the frictional surface. This is called a frictional surface. This one, this black part of it. This is a frictional surface, okay? And their P is pressure is applied here. And the consider an elementary ring. Here we have considered an elementary ring at distance R from the center and thickness of dr. This ring we are considering, we will make all the calculation over this ring, and then we will finally at the end of that we will integrate from R1 to R2, sort of R2 to R1. So we'll get the torque transmission by this clutch. We can get it. So let's move ahead. So you can see in this diagram. Okay, so area of contact, you can see the area of contact or friction surface for this ring. You can see this one. So area we can calculate by under this 2 pi r into multiply this thickness, the 2 pi r into dr. Normal or axial force acting on the ring we can calculate by intensity of pressure and then multiply the area of this ring. So intensity of pressure is P we have already considered, and 2 pi r dr is the area of contact of this ring. And the frictional force acting on the ring, which is acting at tangentially at a distance at the radius r. So we have this this W, that normal force which is acting on the ring, and because it is acting perpendicular to the ring, and the frictional force acting at parallel or in the direction, radial direction of that ring. So we can, if we multiply by the coefficient of friction, so we get the frictional force. So mu into the del W, so mu P2 pi R dr, and the frictional torque acting on the ring simply, as I already told you, this frame, the frictional force acting at the radial at a distance r. So if the we multiply that again r into this frictional force, so we will get the frictional torque, which is we are our objective to calculate here. The frictional torque here is equal to mu p2 pi r dr. Uh, uh, 2 pi dr, and this we can simplify it right like this. So this is a frictional torque acting on the ring, but we need to calculate for whole frictional contact area of the plate. So to solve this equation, this one frictional torque equation, we have two method or we two theory. First one is uniform pressure, and second one is the uniform wear theory. So let's discuss about one by one. So first one is we are considering the uniform pressure. So this, according to this theory, say simply the distribution of pressure is uniform throughout the area of the clutch, or you can the friction surface. So we can define the W is a load normal acting on the friction surface, and we know that area we can calculate. We have the R1 and R2. So we write P is equal to W upon pi R1 square minus R2 square. And you already know what is the W, which is axial force or axial thrust. Okay. So this relation we've already established. The frictional torque acting on the elementary ring. This 2 pi r will be a square dr. If we integrate it from R2 to R1, we will get a total frictional torque acting on the clutch. So let us see. We are integrating from, this is integrating from R2 to R1. So there is a little mistake, just to correct all that. So this must be from R2 to R1. So 2 pi mu p r square dr is equal to, center constant part we can take out. So this is out and we integrate this. So now it's become 2 pi mu p r1 cube minus r2 cube by 3. So let's put the value of p, which is already obtained here. So if you put the value of this and simplify this equation, so now we can obtain 2 by 3 mu w and r1 ka cube, r1 ka cube and r2 ka cube upon r1 ka square minus r2 square. Also we can write the r, and we can consider this is the main radius of this all whole term, and r is equal to, and where r is this. So this is a simple formula in future you can use to find the torque, total frictional torque acting on the frictional surface, and that torque is responsible to transmit power from driver to turbine shaft while clutch is engaged. So let's we consider the second theory, uniform wear theory, and this theory say that normal intensity of pressure which is acting at distance r from the axis of the clutch, the intensity of pressure varies inversely with the distance, and this variation is inversely proportional from the center of the from center of this plate to the radius. So we can write P into R is equal to C is a constant. So P is equal to C by R. This is one equation. So normal force acting on the ring. So simply we already know P into 2 pi R dr. Just put the value of P from in terms of that. So C is come in this equation and R is cancel out each one. So this R is cancelled by this R, and so we can write 2 pi R here. So total force acting on the frictional surface, it can be, we have to be integrate from R2 to R1, this equation, this new equation 2 pi CRD. So once we have integrated, so u R, so we can get value of C, W is equal to 2 pi R1 minus R1, and then again this value we put at the end of the this derivation. So we already know the frictional torque acting on the ring we have calculated in the previous slide. So this is 2 pi mu PR squared dr. Then again we have to be put the value of P again upon C by R. So C will come appear in this equation, and R is deducted or cancelled. So new form is 2 pi mu R and CRDR. So again, we have to be do the same step. We have to be integrate from R2 to R1. Once you have integrated, so as one R is already deducted here, here one thing after deduction, so it's become like this when you put the both limit. So this become 2 pi mu C R1 square minus R2 square by 2, and it's look like this. If 2 is cancelled by this 2, this 2 is 2 cancel out the BJ. You can do the cancel out the you can do again. This one is cancel out, so this become like this, and put the value of C here. So after the simplify, so it's become 1 by 2 mu WR1 plus R2. You can see this. So you can write simplify mu WR, where mean is 1 by 2 R1 plus R2. So this is a final relation you can use while considering the uniform wear theory. So the one thing is that you can see that the multi-plate clutch I've already discussed. In nothing we have to be too much more in the case of multi-plate clutch, that the both derivation is apply, which we have already obtained in single plate clutch, but we have to make one arrangement here. We have to be one the relation we will have u n is equal to n minus n1 plus n2 minus 1. So where n is the number of discs on the driving shaft, number of discs on the driving shaft minus 1, we will deduct minus 1, while the both end side of clutch filters will not take the participation on the torque transmission, so we will deduct by 1. So finally, we can write the number of already you can retain n is equal to n max 1. So we will multiply the number that n we have already calculated the number of pair of contact surface. So the same relation is valid here for the multiplier. So thank you so much for attending this class. In coming class, we will discuss some numerics. Thank you so much.